So let us just revise what we did yesterday, and then we can start with logging. Okay. So yesterday we looked at testing, that is unit testing, and what are the different types of testing that is there in the industry. So it's generally what happens is we know the flow, right? One is from the requirements, and then it gets down to say high level document. Probably it contains architecture and other components here. And then there is low level document where we specify how the code looks, code base looks, and things like that. And then out of this, the outcome is code. Okay. So this is where we plan how the code looks and functions and interfaces and so on at the code level, and we actually write the code. So, and this process, once you uh, are done with coding, what happens is it goes for several levels of testing. So if the high level document or this particular step contains multiple components, like we have news, we have weather collection, and then we have what was the calendar and mails. Right? So calendar is one of the components. So imagine that all these, each of these components are being worked by different teams. So it could be, let us call them as like news team, weather team, and so on. Okay. So this is news team and the weather team, and this is calendar team. So their job is write this code. So code base would be having say single code base. Probably we will have folders called news, which only these guys are owners of this code. Similarly, other parts as well. So when we write the code like this, so uh, each of them takes care of each one of the components. And what happens at next level is after the code is done, we don't put it to production yet. So there are several testing teams. Let us take one testing team. So this testing team could be mapped to, there could be different component testing teams. For example, there could be a testing team within the news team. Okay. And then other components like weather team and so on. So this is for they test these particular components. And there could be another level of testing where we integrate all of this as one product. So this level of testing, so this is, let us call this as component testing. And then let us call this as integration testing. And this is where your integration testing happens. And what this is the flow of software development, right? Once this integration is testing is done, there could be some more testing like security and so on. But once this is done, so this whole thing comes under quality assurance. Okay, so that is what QA. So QA team would be as big as probably development team because they need to ensure that whatever the requirements was there. So they are the like last person to tell that okay these requirements are satisfied and now the product can go into the um, outside world. So which is say it could be in a distributed system or somewhere product which is getting installed in somebody's infrastructure, laptop or anywhere. So if you look at this, so these guys are testing take, so what these guys are testing is requirement documents. So the cross verification, they do requirement level, which means that we are going from here, we are going reverse way. So testing is trying to help us to realize final customer requirements, right? So they focus on the requirements. Component testing teams focus on probably like each one of this high level design, whether the component is working or not. Okay. So component testing, probably it is they check the HLD and then they make sure that at HLD level, whether all the requirements are satisfied. And at the code level, or component testing is done. And then at code level, as developers, what we do is we write unit tests, right? So that is what we learned yesterday. So within this unit test, there are like several things like you can take a function and then write corresponding unit test. And also you can have multiple functions getting called within the function and so on. So finally, what we do is, what is the input and what is the output, what goes in and what goes out. So this we should consider as a black box at a function level. Black box in the sense we do not know what is happening inside that function. So we just write the tests and make sure that the function is working. So there is also another strategy in development, and that is called as what is that? Test-driven development. Okay, so that is called as TDD. So what this strategy means is that before developing code, you come up with the test cases for at your low-level design itself. So, for example, if I have to talk about news, so I would write tests for news that test this website, test get news. So I would provide input. Input is some URL, and output that I'm expecting is some news in list of news. Okay, so that is what we did. So list of news. There could be n number of news. So this is what we are testing. So then we will take the output and do some sort of assert on top of it. So once you write this code, only then you start writing news.py. Okay. So this is called as test-driven development, where you come up with list of test cases, and then you write the code. Okay. So that ensures, this is like ideal way of doing things, but in industry it doesn't happen like this. But once you deliver the code, what is expected is you deliver two things. One is the actual code and test code. So then it gets into DevOps pipelines, and then these guys will pick up from there. Okay. So we'll talk about release cycles and so on in next week. So how to deploy a product. So that is what we're saying. So you can see that we are going from in terms of verification, from requirements till the each of these levels. So this is the actual flow. So that is what we are trying to verify. And finally, if these two things match, that is requirements and the products match, that means your product is QA stamped, which just means it is quality assured product. Okay. So that is one of the this solves, which is like unit test solves one of the problems or one of the assurances that your test code is working. So it is possible that your teams, you can change the teams, and your manager can change, the architects gets changed, and so on. So what is not changing is the product and what is its the requirement. So there are new requirements coming in, and product gets enhanced and so on. So in order to have this thing working consistently, we have all these processes. If we didn't have this process, it's possible that one guy is doing everything and then he changes the company and then your product is gone. So that is the risk companies don't want to take, and hence there is a process for everything. Okay. So yeah, that's about code quality testing, and we also looked at code coverage. This ensures us that okay, most of the code is having unit test coverage. Okay. So that's about yesterday's class and a little bit about how the industry works. Okay. Today we'll look at logging. So yesterday I gave an introduction about logging. So logging, the reason that we are using logging is we have so far we have been using print statements everywhere. So when you run the program, okay, we see something is getting printed, and so this is on the monitor. But the processes which we run, the actual processes in the back end, there are so many processes running in, right? So on your laptop, so they do not print something on your monitor. So even if they print, you won't come to know because that terminal or the process that is running won't have its own monitor or anything like that. So that is disconnected. So print statements are only useful for your local debugging, okay? Local testing or local debugging. So what are the features that logging helps us to overcome this problem? Okay. You can write logs either. So if there is no logging concept or logging library, the one of the ways that you would think is, okay, I have some .py file, and there are several functions, f1, f2, f3, and so on. And each of these functions, I will um, create a file in the beginning of the file, say open some file, my log file or log dot something txt in a write mode or even in append mode, uh, append mode or write mode, w plus. Okay. So where you can append the file. Appending the file is nothing but you write something here. So if somebody else and comes and writes. So if you have written A already, you have to write, the pointer is pointing at the end of the file where you can uh, enter a new line and new data. So that is append mode. Okay. So write mode is it will overwrite this file. So if you have written this data, so this entire thing will be overwritten. And if you write D, and it will be a fresh file. Okay. That is the difference between write mode and append mode. I think append mode is called as W plus, but you don't have to remember this, but know what are the modes. So you are in the process of generating code, you are not writing your own code at all. Okay. And of course, you own that code. Thus, that is the reason you should know the code. Okay. So, okay. So you would open the file and then you will write the log files. For example, if you have an exception or some places where you suspect there could be a problem, so you could write something like, okay, for this, there will be a file descriptor, fd write. Instead of print, you would write something like fd write and then your logging message. Okay. So this is what you would write at every function. So this is not good because there are several problems. If you have multi-process system where you are writing to one log file, your log file could get overwritten, or it could be corrupted, or it is also possible that it is locked by one process and another process is unable to write. There are so many issues with this sort of raw logging. Okay, without any help of the libraries, the inbuilt libraries. So if you had to write your own library, you should be understanding how the file system work and how multiprocess works in terms of writing to a file and so on. Okay. And then you should be understanding what is a queue and so on. Okay. So we don't have to worry about all these internal concepts. So all these things or all these features which are written to in order to solve the problem is already written in this particular library. Okay. So that is why we use one of the libraries called as logging. So We discussed about why logging, and now let us discuss about the features of logging. Okay. So any regardless of any language, if you have a logging library or logging system, what it does is it you can dump it to a file. You write logs to the file, okay, so that you can open if there is a problem, you can open that file and see what is happening, and then you can debug that later. Nowadays, you can feed that file into GitHub Copilot and say that this is the thing I'm getting, error that I'm getting. Can you fix it? Help me to fix it. So it will match that and look in the code, and then it will try to fix it. Okay. So let us understand the features. Okay. So the logging will have one is like it will write to a file, and how does it write? So you can use this logging object in multiple files. Like you have a.py, you have b.py, and so on. You can simply use the same object and then keep writing to the same log file. Let us say app.log. This is the file name. And you can, any number of files or any number of modules can write to this file. So this logging uh, library will make sure that whatever you're writing is getting written. It does not get jumbled, or it doesn't get overwritten or anything like that. So all the file corruption, all these things are taken care. So it will also have, you can also have the typical log file looks like this. So there will be a timestamp at what time that particular line is printed or dumped into the file. So this is required because there could be like several places where you call one module within other modules, and then you need to know the sequence. Uh, Also, you need to know the timings at which they are called. So if you have the timings, you can also guess like, okay, at this point of time, this was called, and this point of time, if this say c.py is calling b.py, and bit.py is waiting for, say, some input from a user or a file or a database or something like that from an external thing. So it could take like 5 seconds to get that. So this is the usual time. For sometimes it could, in an erroneous situation, it is possible that instead of 5 seconds, it could take like 20 seconds, okay, to get this one message. So in such cases, these timestamps help. So we will look at how does the timestamps look, and then there are log messages. So just remember that there is like a timestamp, there is log message. You can also print from which file it is coming, and you can also print the function name and module name and so on. Okay, there are several features. We'll look at that. So this is the like basic feature of logs. And there could be different types of log. So what do I mean by different types of logs is once you have a log, what we generally do in while deploying the code. So there are different levels of or different cycles of the product, right? At one of the point where we are writing the code and testing locally, so at developer end, it is possible that I write a lot of logs, like entering the function, exiting the function. For every function, I'll write enter, exit, and I'll also print parameters and so on. Because for me, it is important to understand how this works. And if I look at the log file, I should have all these things so that I know exactly what is happening. So if you have like lot of logs in one process or in your product, so what happens is it also takes some time to print logs, right? So that itself will become a problematic situation when you deploy the code in the production. So you should be able to write logs in a way that whenever it is required, you switch on something, like for example, you enable the logs or disable the logs. Okay. So if you just had enable and disable only these two options in logs, what would happen is if this code gets into production, so let us call this as production infrastructure, where your code is like running, and here you think that there are so too many logs, and you while deploying the code, you disable the logs. Okay. So what happens in the production is if something is not working, when you look at the logs, app.log, which is a log file that we generated, there won't be anything because you have disabled the all the logs. Okay. So there is a context of logging. So at developer end, so if somebody enables the logs here again, enable the log, again you'll have the same problem because you'll have too many logs and product will be running slow. Okay. So now people thought that, okay, now let us solve this problem by defining different levels of logs instead of just enable and disable option. Okay. So coming to levels of the logs and why it is used. Okay. So let us consider at developer end, I need a lot of logs. So let me call it as debug logs because I just want to debug. Okay. And um, at some point of time, I need just for information, but I don't need to write these parameters or so. But I just need to know when it is entering and exiting the function. So in such cases, I'll probably have another level where it is just info logs. So info logs, and then there could be another level where I want to print only errors. So probably in production, I want to print only errors in the beginning, and when I enable the logs, I should be getting info logs. When after long debugging sessions, even if you're unable to find the bug, you can even enable the debug logs, and then you can see all the logs. So the aim is to put as minimum logs as possible so that the product works smoothly, because logging is a file operation, right? It writes to the file and it keeps on writing. So you don't have to like you shouldn't be slowing down the product because of your logs. And there could be some other levels like errors. The errors itself could have its own levels, like critical error and like fatal error or something like that. So examples of these levels are I was talking about develop at developer end debug levels is just like printing all the parameters and all the JSON files, everything. So info could be just enter and exit. Okay. Error, error logs could be where you face an error. For example, there is a try and except block which we studied. And whenever there is an exception, you print that log. You log that particular exception. Okay. That could be your erroneous logs. And critical logs could be somewhere like you are waiting for, say, you're trying to access a database, and after trying out accessing database for say 3 times in a loop, the code is unable to fetch the data from the database. So this is one of the critical situations where if that is not working, then next steps won't work at all. Okay, so that could be a critical log. So it is up to you to decide what are these levels, like what is debug, what is info, what is error, what is critical, and what is probably fatal. Okay, and fatal could be something where your database crashed, and probably the code which is trying to get this. You're say let us consider that you're able to access the database and you're not able to get the data. It could be like tagged as critical. So just for an example, and fatal could be something where database has just crashed and you are unable to log into database at all. So this could be fatal. And similarly, like if you are depending on an external API, just like we depended on Weather Stack API for getting the weather, if that server itself is down, it is a fatal thing for us, right? Because we won't be able to run the service at all. final product at all. So these are various levels of the logs. We define them, and depending on the situation, we use that, and we can enable and disable whenever you want. Okay. Now let us look at the code, what it means, and then let us try to realize that, learn how it looks in the code. Okay. So here, whether I have pushed the code, you can look at the code on GitHub. So let me just create a file here. Logging. Logging demo.py. So this is a module. So let us understand. There is an inbuilt library. So I would say that, okay, I want to understand various levels of logging in Python and Python. And then write logs to app.log file with basic format. Okay, just to understand. Okay. So you can see that this is in agent mode. Agent mode, as we know, it will start writing the code directly to the this one, right? So this is agent mode. Here is where you set agent mode. So there is ask mode and agent mode, and you can also choose the LLM. LLM is large language models. You can choose the models here, and then you might get, for complex problems, it depends. Like as you experience, you'll come to know that which LLMs are good for what and so on. Okay. So watch out for news and stuff like that for to understand or to try out them. So it has written, right? So this is your agent mode. Let me clear the drawings. So this is the library that we use. This is inbuilt library. You don't have to like pip install it. It's already there. Okay. You can see that module logging. Just if you hover it, you can see that logging practice for, sorry, logging package for Python based on so and so on. Okay. But so where is this text coming out? Coming out? That is because out of the doc strings. So if you write, say, let us see, news.py. So if you write something here, you can see that news.py. So I'll just accept this and import news. Okay. If you just import this, and if you just hover on news, you can see that this particular text that we have given here in the first line, this is a document string, so which is called as doc string. So every module can have doc string, and also you can also have something like doc string here as well. So it starts with triple quotes, and then I'll just accept this. So there is a you can also follow a format like what is input, what is output, and so on. But this is how the doc string looks like. I think I have already covered. And if you go here and if you say news dot script headlines and accept this, and if you just hover on this, now you can see that this doc string just now we added, right? That appears here. So this helps the developers who are working on these modules or using those modules to understand what it does. So that in your IDE, it is supported. So the places where you do not have IDE, so just you can do like this, for example, code here, and then you can do something like uh, let me just enter here and import news. Okay. So if you do not have this IDE, so there could be places where you don't have IDE. For example, you have a lab and you logged into a system which is running in production. In production systems, you don't have the luxury of having an IDE. And then you do this and you want to look at docstring. So as you know that if you just do dir, it gives a lot of double underscore functions. So one of the functions called as double underscore doc news, double underscore doc, double underscore. This is the place where it gets stored. You can look at this. So slash n is a new line, which is this. So if there is a new line, it is a backslash n in Linux. So this is where it is stored, and that is the reason that you're able to see these doc strings automatically when you hover on it. Okay, so okay, that's about how to include doc strings in modules and things like that. So let us go back to logging. Where was I here? So this is your module, and then there is a function called as basic config. So with this takes in some arguments like file name, level, format, and so on. So this is a basic format. So this is the file that I want to dump the logs to, and I'm setting the logging level to debug. I'll tell you how these levels are set and what logs gets printed. Okay, so let us just run the. So what I'm trying to do here is, in from line number like 11 to 15, I'm using various different levels just to understand how these levels are enabled and disabled. Okay. So now what have we enabled? We have enabled in line number 6. This is what we have enabled. Okay. So let us run this program. Okay. You can see that nothing is getting printed on screen. Simple reason is we are not using any print statements, but logging statements, right? So where are we expecting the logging to be dumped? In app.log. You can see that we have created an app.log. So this library already has created, and you can see that in this log file, you can see whatever we discussed a while ago. So just to explain with the code, you can look at this particular format, right? This is nothing but your timestamps. Timestamps are nothing but your date and time. Okay. So it gets the date and time from the system. And today is 1st of May. You can also change this, change the order and so on. And 2025, what time is it now? It's 7:50. And you can also print at seconds level. Even also you can also print at milliseconds level and so on. Okay. So okay, so these are probably, I don't know what is this. So let's see what is this. You can how can you see this is by just looking at format message hyphen message log level name, and okay, I think the time itself has its own format. Yeah, this is also time. Okay, probably this is milliseconds. I don't know, but yeah. And we were also printing the level name, which is nothing but this. Okay. Now you can see that ID or any good notepad, which is like Notepad++ or even VI editor, if you have some plugins, these things will get highlighted. Okay. So it will automatically make it in a different color so that you can understand what is the meaning of this. Okay. And then it has printed everything. So if it has printed everything because of Only one reason, because we have set it at debug level. So at debug level, everything gets printed, right? So the order is like debug, info, warning, critical. That means if you just enable debug, not only just debug gets printed from debug level to everything else. So that is the meaning of these levels. Okay. Or else what would happen is if you just enable debug logs, your actual critical and error logs also won't get printed. So we don't want that. So if you enable debug, I should have debug also plus all of this. Okay. So if I enable info, what would happen is info from info till here. So what would not get printed is debug logs. So if I just enable warning logs, what would get printed? Warning logs plus the errors and critical logs. What would not get printed is this. This one get printed. Similarly, error logs, error log plus critical logs, and this won't get printed. So that is how the logging works, because you want, of course, you want these things to be always enabled. Of course, you can disable, but if you say debug level, and all of this comes within that. Okay. So severity is always like debug, and then there is like definitely next level, debug level, and info level, and then warning, and then error and critical. So if you just enable this, everything gets printed. If you just enable this, so this just imagine it like a nested data type that we studied, right? So it's like that. Let us now demonstrate, or let us look at how I'll just enable, say, warning. Okay. I'll run it again. Okay. This is how you enable it. You don't have to remember this. So these are called as flags. So flag is where internally it is in probably a bitmap where you just enable one of them and it gets printed. Okay, but yeah, this is not a function. This is uh, this is a variable inside this module. You can actually work on the model on GitHub and look at what each of these things do. Let us run it again. Now you can see that it got executed. Let us look at log file. So this was, until this was our old logs, right? So these are old logs. You can see the timestamps at 50th minute. So at 55 minute, which is now, this is what we printed. You can see there are only 3 messages. What is missing? Debug is missing. Info is missing. The reason is because we have enabled at warning and warning plus everything else. Okay. So we get all the rest of the errors. Similarly, you can try out different other levels. And generally in production, what we do is we just enable from warning or we don't enable info, and we just enable from warning, and everything else gets printed because these are critical. So how do you, coming back here? So we understood how the logging works. So how do you make sure that um, this particular logging um, is used in a way that where do you use critical, where do you use info, and so on. Okay, let us just take some place where we did loops. Is it loops? Okay. Some place where we had existing code. Okay. So let us take here. Let us get here. So in agent mode, so you shouldn't, as we know that one of your thing is, if there is an way to generate the code, just generate, don't write yourself. Okay. So agent mode, I'm going to say that add logging to this file. Ensure exception are covered in uh, critical logging. Every function uh, must have enter and exit. What sort of logs? Info logs, or you can have debug logs as well. It depends, up to you, like how do you like debug logs, because debug is like everything gets printed, all the logs. Debug logs and some places info, some places warrant, which you can decide. Okay, so let us just enter this. So we are in agent mode. So in order to write this, right? Even write this. So one of the misconception that we have is, okay, now everybody can generate the code and write code and deploy the products. Of course you can, but if you do not have awareness and the design in your mind, it won't scale well, and the product is likely to fail. And if as it grows, number of people managing the code grows, and when more people are involved, there should be a process. I have explained why you need to have process, because people keep changing, they can quit the company and so on. So in order to even ask, you should know the concept, right? Now we know about logging, so we have specified like what sort of logging I need and so on, and which places. And then we have generated the code. Coding was never a problem, because even before chat GPTs and this agent mode, we had like, we used to do this manually, right? You go to Google search, and then you'd go to Stack Overflow and then get the information, or you go to GitHub repository and then find the examples and copy paste it, and then modify the parameters and then make it work for you. So now these agents are doing the same thing, but like probably 10x faster, 100x faster. Okay. So that advantage, but the basic concepts that you have learned so far in the coding, that will never go wasted, because you need to ask it in right way, right? So you should know what to ask and how to ask. So that is where your prompt engineering skills comes into picture. So now let me just keep this file. Let me just verify this. Okay. So for example, this logging app basic cloud. Okay. This is app.log. Okay. And get number of entries. I have asked it to add debug logs for entry and exit. So you can see that it has done that beautifully. And then I have asked, whenever there is an exception, do this. Okay. So number of entries, invalid number of entries, and so on. Okay. So collect data, and then I'm just looking at collect the data, which collects the names and pages. So we did this in our loops class. Okay. So now I have done this. So now let us save this file, and let us try to run this file and see how it works. Okay. How the logging works. So this was the program, if you remember, and it asks how many people's data do you want to enter. Let us say 2. Okay. Name of the person, say Digant. Enter the age. So enter some other one, say age, like say 22. Okay. So you can see that we had simulated one of the errors. Okay. So this bug always get executed regardless of. So now we also have prints, and we have also logs. Now, if you just look at this, and the people who are managing your product, they won't have the code base at all. So they're like, for example, I have downloaded VS Code here. I don't have the code source code of VS Code, right? Of course, I can go and look for it, which is open source code, but it is not readily available. So I'm just a user. So if there is some crash or some feature is not working, I would go to like help, and probably I'll write a mail or report a issue, something like this. So this is where you report a issue. So this goes to the support team, and from the support team, it goes to finally developers, and then they match this. So imagine that this is the data that they are getting out of support team. So if they have this, what would they make out is, okay, they know the flow. Okay, this is what is happening, but they also might want to know like what is the timestamp and so on. Now let us look at app.log. Okay, let me drag it down. Okay, so this is our new set of logs that we have written. Okay, from here. Okay, you can see that program started loops.py. It is coming from. You can also use right click, split down, split left. You can have two files like this side by side to match. So this is your log file. These are the new log. So you can see where it is coming from. So program started. Where is it? Loops.py. You can search here. Okay. Here it is. Okay. Program started loops.py. So now you know the sequence of the errors. Now what we are trying to hunt down is there is an error, index error in collect data list out of this one. So now let us go to that particular error. Okay. Find out that index error in collect data. So let us go to that particular collect data, and let us go to that. So you can see that we are here. That means now we know that, okay, this is the point where I have uh, I have the error. Now I can go and see what happened before this. Just before this, what happened was, okay, it was collecting the age of some person, and it went here. And now we can easily debug that, okay, collected one. So for Digant, it worked, which is 44. For Bhuvan, it did not work. So then you can hunt down, okay, what is happening here? Okay. Age and so on. So this is how you can debug. Okay. So with this, you know the sequence, and what you'd get from support team is, if this is a lot better than just this, right? And also you can enable line numbers. For example, I can say, I'll just show you, and then we can close the session. You can also enable, let me close this. Right. Go back here. Set line numbers and function names in logging. Okay. Now I can see that we will have enhanced logging, which will give more hints for us. It is making changes, it is generating the edits. I can see that what was changed is, from this we added function name and line number. You don't have to remember the syntax. You remember that these are the features that is there. Okay. So I'm going to keep this changes. I like it. And then you can again run the program and say to person one Digant and say some age. And then you can say, now you can see that something happened here. Okay. So, and then we got the error and so on. So let us look at the log file again. So what is happening in the log file? So this is the new set of logs I have written. Now let us look at this log. So you can see the difference now. It has appended the log files. So these are the new set of logs that is coming. It has got the function name as well, and also it has got the line number as well. Now it is even more easy to debug. So instead of getting this just this printout from the support team as a developer, imagine that you are getting this file, which is accessible by support team, by the way, because once the product is running, you also get the log files, right? Log files is getting dumped in the at the product end. So you take this and then you can easily focus on, say, critical index error. Okay, where is it in the correct data? And then it is in line number 49. You can simply go there, line number 49. And now you can like pinpoint what is happening at this point, right? So that is the usage of log file. Okay. So yeah, that's about what I wanted to cover, and I hope it was useful. Try to do the assignment so that you get hang of it. Yeah, thanks for attending the session, and yeah, take care. See you. Bye. Tomorrow there would be class. Okay. See you. Bye.